Good day, everyone. Thank you for joining today's Docker webinar. A few housekeeping items before we get started. As a reminder, this session is being recorded, and a copy of the recording will be sent out a few days after the webinar. We will take questions at the end, so please post them in the Q&A window located in the lower right of your screen, and our speaker will address them at the end of the session. I would like to introduce today's speaker, Jim Armstrong, Product Marketing at Docker. You can catch Jim on Twitter at @JDArmstrong or on Docker Slack at jim.armstrong. I will now turn things over to our speaker, Jim Armstrong. Jim, I think you may be on mute.
Got it. Yeah, I'm off mute now. Thanks.
Perfect. We can hear you.
All right. Wonderful. Yeah. Well, thanks everybody for joining us and for this presentation. So today we're going to talk about securing the application supply chain with Docker. As we stated before, if you have questions, feel free to type them into the Q&A panel in the bottom right corner of your screen. We have another panelist on here, Jenny Fong, who can answer some of your questions as we go through the presentation, and then I'll answer a few at the end as well. So with that said, one thing that I do want to do before we dive in here, I think particularly for this discussion, it's important for everybody to level set and understand what the Docker components are. Because there's a number of them that we're going to talk about today. Most people, when they think of Docker, think about the container runtime. They think about, the actual engine that pulls down containers and executes them. But there are a number of other pieces of Docker that are particularly important when we're talking about security and we're talking about the application supply chain. And so I want to make sure that for those folks that have joined the call today that may be a little bit new to Docker, you understand what the components are and sort of how these pieces all fit together. So there's the container runtime. That's the Docker engine itself. It's the piece that I think most people are sort of innately aware of when they think of Docker. There's also orchestration. And so you probably hopefully heard recently that Docker will soon support Kubernetes as an orchestration engine. That's where this fits in. We have Docker Swarm today that's part of the overall package. And then there's a number of other things that sort of circle around the engine and orchestration that are still at that base layer. These are essentially the open source components, the community edition components of Docker. So there's built-in security pieces that we're going to talk about today. There's networking, there's storage, which we call volumes, and there's some state information. That's all part of the base layer image. And then on top of that is where we really get into some of this lifecycle management components, the pieces that more often people use in the enterprise edition of Docker. And we're going to touch on pretty much all of these components as we go through this today. But just wanted people to have an understanding of what Docker really is and to know that it's more than just the container runtime that we're talking about. There are actually a whole suite of components that fit together to make up Docker, as a whole, the whole supply chain. And so we're going to go in through those as we talk about this today. And we're really going to focus on the security aspects of it. So as you build out this supply chain, we're going to kind of start way at the beginning here, how you actually build applications and where those containers come from, and then go all the way through how they run in production. And we're going to focus on three sort of key tenets here. The first is, as you build those applications, as you start with your containers, how do you build integrity into the applications? How do you ensure that you know what is inside those containers themselves and where they've come from? Then we're going to talk about, in this middle piece, how we deliver those applications, how we actually can automate some of this supply chain, and how that whole thing works, and the security functions that are in place there, so that we only promote software that's good, that's clean, that we can verify. And then how do we actually run this? And this is critical. We're going to come to it last, but it may be one of the most important pieces. Particularly for those of you in operations, how do we actually run the software in a production environment? How do we control who has access to it and make sure that the environment itself is safe for our containers, for our applications to run? So we'll hit on all of those. The other big piece about this is this whole supply chain and all of this stuff that we're going to talk about works whether you run it in your own environment, your own data centers on-prem, or whether you run it in the cloud, or some mix of the two. You can take certain pieces of this and put them in the cloud if you think that that's a better place for them, or you can have some of them that run on-prem, and you can mix and match those two. But it doesn't change anything that we're going to talk about here today. That choice of location is completely independent of the functionality that we'll talk about here. So let's dive in. Let's talk about first how we really build a container, how we build integrity into our applications. And it really starts with the container itself. And at the very beginning, where do those containers come from? Who builds the containers, and how do we start building these images? Most users, particularly those that are new to Docker, but even those that have been using Docker for a while, will start with an image from us. Actually, so we maintain, Docker Hub, Docker Store, and we have a number of images that are out there. And generally speaking, there's 3 tiers of images that are out on Docker Hub. There's the certified images, there's what we call official images, and then there's the community images. The certified images, those are images that we work with our software partners, our the ISV partners, and we both go through a process of ensuring that what they hand to us is authentically from them, that they maintain that image on a regular basis, and then we add our own security scanning to that, and then we sign the image as well. So there's a number of checks that go on between us and the vendors for certified images. The other thing about certified images is we're not just certifying, the source and of the image itself, but we're also certifying that it runs on the Docker platform too. So there's an additional sort of supportability guarantee that comes with certified images. That next tier down we call official images. Those are images usually that Docker has put together, but we go through a lot of the same security checks. So if you think about, the certified images include things like OS images and things. So we get stuff from Microsoft, for instance, and that becomes a certified image. On the official images, we go through a lot of the same security checks. We go through the same image hygiene. A lot of times it's Docker that's maintaining those images. And we also sign those images, but they tend to be more open source things. So if you go look for Node.js, for instance, there's an official image that's out there. But there's not really an ISV that would be a certified partner, so to speak. But it goes through the same security checks. And then there's the community images. That's the 3rd tier. And the community images can really come from anybody. You could submit community images yourself. So there's less of a guarantee about those images. You can still go through and find images that come from trusted vendors. You can find images that come from, potentially partners or, developers that and so you may have your own level of trust for those images. But generally speaking, it's kind of the wild, wild west. So those are the 3 levels of images. By and large, if you get those images from us, particularly the certified and official images, when you get them, you can verify all that. So you can verify that it came from us via the signature, and you can do your own scanning on these images as well. So you don't have to take our word for it. You can actually scan the image and get your own bill of materials so you know exactly what's inside there. We go through it layer by layer on the image. We tell you all of the binaries that are inside of it, and we look for vulnerabilities as well, and we'll identify all of those things. So when you get those images from us, that comes from us, and you know exactly what's inside of it. You can even set controls to say that you're not going to allow images that don't have those signatures to run in your environment. So now you've got the images. Of course, you're going to start adding your own pieces to it, to create your own applications. And as you do that, layer by layer, as you build this up, you can continue that same process. So internally, you can kind of self-certify these images. You add a layer, you scan it so you know exactly what's in that layer, and you sign it so that you know exactly where that layer came from internally. You can trace it all the way back to the original user who created it. And in fact, you can set controls as well. So if a signature is invalid, if somebody's tampered with your containers, that would invalidate a signature. If a user is left, it doesn't, you no longer trust their signing key. Or if you find vulnerabilities in the software as well, you can in fact stop that supply chain so that that software doesn't continue on through the process. So there's a number of controls that you can apply to ensure that all of these checks are met, that it is scanned, that it is clean, that it is valid, and comes from a trusted user. and not allow things to go through that supply chain if they don't meet those checks. So that's kind of the first level of automation in this whole supply chain. Now, of course, as you build your images internally, most likely, in a lot of, pretty much every enterprise case, we find users that don't want to share those images or store those images out on Docker Store or Docker Hub, which are public locations. They want a private location where they can store their own software, and we provide that in the Docker Trusted Registry. So that was one of the components that we talked about as part of the overall Docker software. The private registry is your own location to store those images. You control who has access, and you control what images go in there. So we'll dive a little bit into some of these components before we move on to the automation phase. So the registry is sort of the key component, I think, to this particular stage, right? It's where the images are stored. A lot of the actions that we're talking about, the scanning and the signing, is tied in directly to a lot of the registry operations as well. So the registry itself, and first I should point out that you can have multiple registries. You're not limited to just one. You can create as many as you want when you have the Docker software. But again, you can control exactly who's allowed to push software into the registry. You can control who's allowed to pull software out of the registry, and you can do these things like verifying the signatures and enforcing scanning policies. Another thing about those registries is you can turn on this feature called immutable repository. So repository, you think of the registry as the whole library of software. A repository would be an individual application inside that. And you can turn on this thing called immutable repositories. And the thing that's great for is preventing, in particular, preventing accidental changes. So let's say I check in a version of software and I've made some changes and it's a version 1.2, I've called it. And then somebody else was working on the same software where they can't overwrite my version 1.2 with their own 1.2. So it enforces the ability to go back and check all the different versions of software and to really, identify the entire chain of custody for a particular application and trace it all the way back to its origins and ensure that nobody accidentally or maliciously comes in and changes software. And that works, by the way, whether it's manual, like in my example, I'm manually pushing software in there, or if you have automation systems that build and push and pull software from the repository as well. Both of those things, can be affected by this and enforced with this immutable repositories. The other feature, the signing of the images, is also something that's tied in pretty closely to registries and checking in the software. We call it Docker Content Trust. So as as a developer, as I build an image, I would sign it, right, to say that it came from me. And that signature goes beyond just saying that it came from me. It's tied to a particular version of the image, what we call a tag in the concept of the registry. And it tells not only that it came from me, but it says exactly what's inside the software as well. It verifies what's inside there so that nobody can tamper with that software after I've checked it in, because the signature would then be invalid. It also, and this is important too, it also stamps with the time signature, so we can tell exactly when that software was submitted. You might want to set a policy in your environment that says that if people aren't regularly maintaining your applications, you're not going to allow them to run, in your production environment. You want to ensure that things are being up to date, that somebody's maintaining and monitoring these applications. And so that signature also gives you that time stamp, that born on date, if you will. So you can verify all of those things via that signature, that signing of the image. And then the scanning that we talked about, right? So again, for every layer, if you think about the containers themselves, as you're probably aware, they're made up of various layers. Well, the scanning goes into every layer of that image. It'll tell you what's inside that layer, so it'll give you a list of all the packages that are part of it, and it will also tell you the vulnerabilities. So we match it up against a CVE database to tell you what vulnerabilities are there. So if it's got critical vulnerabilities, major vulnerabilities, and so on through the various classifications that are part of the CVE database, we'll tell you exactly which packages have vulnerabilities and what level of vulnerabilities those are, and link back to CVE if you want to figure out how to save those things. And all of that can, again, be done automatically via policy. So if somebody pushes software into that repository, into the trusted registry, we can have it automatically scanned and set policies then to say, okay, if we find critical vulnerabilities, we're not going to allow this software to move, to move any further down our supply chain. If it doesn't have the right signatures, if the signatures are invalid because the software has been tampered with, we're not going to allow it to move through our supply chain. And it's really kind of a powerful concept, right? As you think about these layers, this process happening throughout is particularly powerful because you can identify the source of every layer. You can identify exactly what's inside every layer. You have this whole trusted chain of custody, as I said before, about every layer of your image and where it came from. And if something happens at a lower layer of your image, you find a vulnerability or something else is wrong with that particular layer, right? The layers on top of that shouldn't be used either, because you don't want to release software that's got vulnerabilities at any level. And so you can go back, and this gives you this whole chain of custody to go back and say, okay, we need to fix this, in this example, this PyPI base layer, and then we can rebuild our app on top of that so that we get a clean image that goes out to the next phase, particularly into production. All that has to do with what's inside the image, but what's not inside the image is equally important. And let me close a window here. This kind of ties into a kind of a secure development methodology, which is essentially stating that, look, anything that's security related, anything that's particularly sensitive, shouldn't be hard coded into your applications. This would apply to sensitive data, but also to things like passwords that you use to connect to services, API keys, connection strings for that matter, metadata about the configuration of an application. Those types of bits of information that from a development standpoint, it's easy to code them in. It makes it fast and simple to test and all those kinds of things. But in a real, scenario, when you're running these applications, you don't want those things to be there. Somebody that gets access to your source code shouldn't have the password to connect to the database, for instance. The operators who are testing these codes and running your applications in production don't necessarily need to know all these passwords either. And so that's something else that, from Docker standpoint, we can support. We call it secrets. And essentially what we're saying is we'll take those things like passwords, connection strings, those bits of data, and we'll store them separately from the containers themselves. And we'll set a policy such that when those things are running, we'll match up the right secret with the right application and at the right time as well. And if you think about this, as a supply chain, the password that a developer might use might be very simple when they're developing the application just for testing purposes. As it goes through various levels of testing and on into production, that password may become more and more secure. And to the point where even in production, maybe nobody really knows what the password is. It might be completely hidden from them. But Docker can also match up to that process as well. So we'll match up the right secret at the right time with the right application and keep these things separate. And again, the operators don't need to know what these passwords are either. So we're keeping that separation of both separation of responsibilities as well as separation of the code from the sensitive data itself. All right, so let's move on to that middle kind of step in our supply chain. This whole notion of secure automation. Now, not everybody is fully automated at this point. I think a lot of our users have some degree of automation, but they're still kind of exploring how they get to that next phase. But I think there's some great things in this phase that will help with that, even if you're not automated at all. So if you think about this, once we've built the application itself, it's going to go through various phases before it gets to production. You probably have your own names and steps and phases along the way. Maybe in your environment, some of these are automated, maybe some of them are manual, but the concepts here will apply in either case. And there's some automation that Docker can provide, even if your steps are all completely manual, to help here as well. And the other thing about this is that, generally speaking, you're not running one application, you're not building one application internally, you're building potentially hundreds or thousands of applications internally. They may all have their own supply chain process to get to production. And you also want to match those things up too. So you want to control, who has access to these things, to various applications, who can build the application, which we talked about as part of the registry, controlling who can push and pull software, but also controlling as it goes through these phases, who and what has access to our software. So as we go through this process, we're going to follow that same methodology that we talked about, where we sign things and scan things at each phase. That signature essentially becomes a stamp of approval that we've passed a particular phase and it's ready for the next phase. And that helps us set up this whole automated chain, ensuring that software only goes to the next phase when it's been approved by everybody, every step before it. And so that when it gets to production, we have this entire chain of custody. We can verify the entire chain of custody that's passed all the right steps by all the right people or processes, and that it's secure from a vulnerability standpoint as well, so that we can run it in a secure fashion. Right. So what's tied into this is several different concepts. One is the notion of access control. Right. Who can run our software? What level of access do they have, and not just to the software, but to the actual nodes where this runs and to things like the secrets that we talked about before. And so you have a lot of flexibility with Docker Enterprise Edition to set these controls. We call this a grant inside the software, but it's really just matching up, the who, the what, and the where in terms of software, in terms of adding software, running software, and managing and operating the actual environment itself. So that's a very important and very powerful concept. And it really doesn't just apply to this middle phase, it actually applies to the whole entire supply chain as well. But again, if you think about this, right, what we're doing is at each step, we are verifying the keys that came before so that we know exactly where the software came from. We're scanning it, we're adding our own signatures, so we're sort of certifying this at every step along this process. And again, whether these phases are manual or whether they're automated, most customers are pushing to get more and more of this automated. But even if they're manual, these same steps will still apply. But the powerful thing here is this policy-based automation for it, so that even if the steps are manual, you can start to automate and start to build in some efficiency. So you can build in through Docker this policy that says, look, you can't promote this to that next step in its journey unless it meets certain criteria. So it has to have 0 critical vulnerabilities, for example. It has to be tagged a certain way. So we're only looking for things that are tagged with a certain version number or certain, it has to be called the latest or whatever the case may be. It has to be signed by, X, Y, and Z before it can go to the next level. So all of those things can be part of our policy that determine when software moves from one phase to the next. And again, even if the phase itself is manual work to check in, run the tests, and check back in the software, the process of moving that software through the supply chain can be automated with Docker. So then we get to the final phase. And again, as I said, this is probably one of the most critical phases in the whole thing, particularly from an IT perspective, from an operator perspective, is how do we actually run that software in production? And there's a number of layers here that are really important and really important concepts. So starting at the kind of the base layer, the most atomic layer here is the container itself. And it's important to understand how containers run in the notion of, that multiple containers can share a single operating system kernel, but there's safety built in even to the default way that containers run. So if you don't do anything beyond what the Docker engine inherently does, there's some security capabilities built in. The goal here, of course, is if somebody, or maybe I should say when somebody gets access to a particular container, a bad actor, for instance, we want to ensure that what they can do is very limited. Beyond what's available inside that container. So things like separating the secrets out was important, but also what does that user then have access to once they're inside a container? Well, the notion of the container itself, and one of the reasons that it came about and we call it a container is because it is its own little sandbox, it's its own little environment. They share an operating system kernel, but the container is an abstraction away from that kernel. so that multiple containers running on the same operating system are running in their own namespace, their own sandboxed area inside that. So if somebody gets into a container, what they can do by default is pretty limited. A lot of their capabilities on the host operating system are reduced. A lot of their access to files and things on the host operating system are reduced, and that's all by default. There are additional controls if you really want to secure things that you can apply to the container as well. You can drop additional capabilities. You can remap users. There are a number of things that you can do beyond what's there by default. But even if you just stick with what Docker does inherently, there's a good level of control over what happens at that container layer. The other thing about this, when we talk about running safe, right, we kind of separate the word safe from secure. Secure means, you know, we've got tools and things and different capabilities that we can add to add protection and add layers of defense. But safety is the notion that, you know, something might break and we need a way to fix it very quickly. And the great thing about containers is, you know, when something breaks, the process of fixing it is changed pretty dramatically. You don't connect to a container and install a patch and, you know, then bring the container back online. You don't, you know, go into the container and do a lot of research to figure out what's happening. Instead, you just simply replace the container. It's essentially, you know, ejecting the broken container and replacing it with a good container. And it becomes that simple, and that's the same process you would use if you're upgrading software, if you're deploying a new version as well. The Docker will help you roll out that, but the essential process is we eject the old containers and replace them with new containers, and there are various methods and controls for how that process works. The other piece of this, when we talk about a broken container here, it's going back to that supply chain and saying, you know, we found something that's broken, we need to fix it, let's not push that software out any longer into production, and so you have the ability to do that as well. Now, kind of expanding from there, right? Applications usually don't run as a single container. There's multiple containers that make up what we call services that go into a full application stack, and part of that is networking those things together. Usually that starts at the development, you know, phase, right? So the developers are going to wire up their containers that are part of their service in a certain way and set controls over which containers are allowed to talk to other containers. That's all inherently built in, again, to that Docker engine itself. With the control aspect that you can even do things like encrypt that network. So that little network that connects just privately inside of an application can be encrypted if you want it to be. All those things are part of how we compose an application. So if you've heard of Docker Compose before, it's the file that determines how this application is run and how these services are wired up, and all of those controls are part of that. Now, when you're running multiple applications in your environment, you also want to control which applications can talk to other applications. And again, by default, each application is isolated. As an operator, as an administrator, as an application builder, the determination has to be made to explicitly allow applications to talk to each other. Otherwise, you know, each of those segments is essentially private. So you have controls for all of those things in Docker as well. And then, you know, you want control over where these applications actually run. So these are all going to be running on hosts, whether it's in the cloud or whether it's your own servers in your environment. They're going to be running on some hosts, and you want to make sure that you have a layer of control over that as well. And so that's where the Docker engine really sits, and a lot of the, you know, components that are part of that Docker engine make up this cluster of nodes. And the way that this cluster works, there's a manager denoted here by the gray node, and then there's worker nodes, which are denoted here by the white nodes. Generally speaking, the managers are there just for command and control, and the workers are there to actually execute the containers and run the services themselves. But that manager is in charge of setting up a secure infrastructure. So the manager, when it's communicating with the workers, all that traffic is sent out over encrypted connections. Everything is verified cryptographically so that the workers can actually authenticate that the command that they're receiving comes from the managers that are part of the environment. If we want to add a new node to this environment, it has to be joined in a secure way as well. We can't just randomly join any node. We have control, of course, through the role-based access controls over who can add a node, but there's additional controls and keys that are used to join a node to our cluster and then to set up this secure communication between the manager and that worker. And beyond that, if you want the workers, any traffic that passes between them or amongst them to be secure, you can set that up as well so that all that traffic would also be encrypted. And of course, part of that is ensuring, as I said, that any commands that are sent to the workers, instructions on how to run or what to run, that those are authenticated as well, so that the workers know that they actually come from their managers and not from, some random place or bad actor. The other piece of this, and again, going back to that notion of safety, what do we do if something goes wrong? And in this case, kind of the worst case scenario would be, what if somebody steals all those keys? What if somebody somehow gets access to all the keys and certificates that are setting up this all this secure infrastructure and the secure communications amongst our nodes? Well, I mean, the worst case scenario would be you just destroy everything and start over so that you get fresh keys. But that's not realistic. That's not a great way to run in production. You can't take all your applications offline so that you can rebuild your infrastructure in the event that somebody, as unlikely as it may be, somebody steals those keys. And so we've built in capabilities to even handle something like that in Docker. So essentially what we would do is set up a new keys. We can roll out new keys to all the nodes. And once we've secured communications and command and control via those new keys, we can then revoke those old broken keys so that those are no longer in use, and whoever stole them would no longer have access to any of our nodes again. And all of this can happen while our containers and applications continue to run in the environment. There's a number of things that we can build in here that will help us, secure what's running in the Docker environment. This notion of the role-based access control is extremely powerful, because if you think about that cluster of nodes, right, some of them may be just for developers to go and do some testing. Some of it may be for the various phases of testing that you have along the way. And of course, you're going to have your production infrastructure as well. And who can operate on those various, pieces of infrastructure, exactly what they have control over and access to is extremely important. And that's a piece of what you can do with the role-based access control. But the other side of it, too, is actually controlling the applications. So here, for example, we've listed PHI, protected health information. It could be anything, PCI, HIPAA, any regulation or anything. Anytime when you have a particular application that must run in a certain location. So let's say you have some nodes that have been certified for this PHI application, and you have additional controls outside of the Docker world that apply to those. You want to make sure that those applications that are touching any of this PHI data only run on those PHI nodes. Well, you can do that through the Docker system. So this role-based access control also applies to the actual applications themselves and the nodes, so that we can enforce constraints and say this PHI application can only run on nodes that are designated for PHI as well. So there's a number of layers that go into this role-based access control that are really important for how we divide up the nodes, who has access to them, and also where our applications can run. Now, all of these things, need a way for you to easily manage them, particularly at scale. As you're, scale out to hundreds of nodes, and you have, all these different development, life cycles and teams and people that have access to this. And so the piece that really controls all this is what we call the universal control plane. That is the front end to this. So all of that, like when we're talking about role-based access control, if we're talking about the trusted registry, those promotion policies and the scanning, everything that you've seen from that perspective is all controlled via this universal control plane UI. And then, running the applications themselves, where they run, how they run, monitoring the applications, that's all part of the universal control plane. So to wrap up here, we talked about this whole supply chain. We talked about how we build integrity into the applications, verifying where they come from, signing them so that as we build applications, we know exactly what's inside the application. We know exactly who built it for us. And we can set up our own internal certification process and store that in our own private registry and support secure methodologies where we keep things like our digital secrets outside of and separated from the code itself. We talked about how we automate the supply chain. Again, your steps may still involve a lot of manual work, but with Docker, you can take that first step towards automating the supply chain. And if your steps are already fully automated, if you're doing a lot of the CI/CD type work, that works great with this as well. It's all automated via APIs and controls. But the same exact process applies either way. The same promotion policies would apply either way, so that when you get to production, you know exactly where your application came from and what's inside it. And then we talked about how you run in production, how everything is secure, even at the default layer. If you don't do anything else, you have great security with the Docker Enterprise Edition. And then you have the additional access controls, the additional authority to set these things, and maybe even most important, how you can fix things very quickly, whether it's a broken container or whether it's something as dramatic and drastic as the actual engines themselves. Somebody stealing things like security keys that secure that infrastructure layer. And again, all of this works whether you're running this or running some of these pieces on-prem or some of these pieces in the cloud, or all of one or the other. All of these methodologies and techniques apply. All right, so just a few things here when I'll go into the Q&A. There's lots of things you can do from here. I'll point out a couple of things here. There's an IT Pro website. So we've been running this series called A Day in the Life. You go to the IT Pro website, you can keep track of the Day in the Life series, as well as additional assets and things that we're posting out there. We have some training available, including a Docker security course. So if you're interested in that, there's a site. You can also get certified in Docker if you want. Specific to security, this week we released a couple of new things. So there's a guide out there to building a secure supply chain. It'll talk about a lot of the things I talked about here, but it goes into a good bit more depth on some of these. So it's great reading if you want to get into a bit more of the details. And there's a reference architecture. So reference architecture talks about putting all these things into a sort of a production environment and tying in some CI/CD tools as well, some non-Docker pieces. So I think that's a great thing to see how you can actually operationalize these with a reference architecture stack. And then the final thing I'll point out too, we do have a short poll. If you have time, it's only 4 questions. They're all multiple choice. It'll take you 2 minutes to go through the entire thing. But if you have time, I'd appreciate it. It's docker.ly/admin poll. And it's just for us to try and figure out some things about how and who is using Docker in their environment. So I really appreciate it. My contact information is here. And at this point, I will look for some Q&A.
Yeah, so just a reminder for everyone, if you do have any questions for Jim today, please drop them in the Q&A window, which is in the lower right-hand corner of your screen, and we can take those questions now.
I only saw one question come in. There's a couple more coming in right now. But the first one is, can the registry be hosted locally?
Yes, yeah, the registry can be hosted locally, so you can run the registry. In fact, that's exactly what it's designed for, is for you to be able to run it locally. So you would run that in your on-prem environment. You can run it in the cloud as well, so you would run it in your own private location in the cloud. But if you have a cloud infrastructure, you can run your own registry in, say, AWS or Azure if you want to host it there as well. And you can run multiple copies. We don't limit you to any certain number of registries. What some people will do is they'll have a registry for developers, and they'll have a registry for production, and various use cases for the registry. So you can run multiple registries if that's what you prefer to do as well. But definitely, it's designed to be your own registry that you run, where you choose.
There's also a couple questions about the reference architectures you mentioned. I will put those links into the Q&A right now, but they're both coming from the site success.docker.com, which has all of our reference architectures and knowledge base articles. But give me a minute and I will add those into the Q&A window. That was it. Yep.
Yeah, I was just scanning through to see. Yeah, so these slides will be out. There were a couple things about links. I think these slides will get posted as well. So the links are, those things you saw have links in there as well, but definitely get those out to you. If you don't find them, please email me, jim.armstrong@docker.com or Slack or Twitter or whatever is your best way.
Okay, the links have been posted, so you can find both the Securing Docker EE and Security Best Practices, as well as the Building a Secure Supply Chain reference architectures. And I think that's it.
Okay, well, thank you, everybody. Thank you, Jim. Thank you, Jenny. This does conclude the webinar today. A reminder, as Jim had mentioned, that the session was recorded and a copy of that recording will be sent out to you. Please be sure to register for upcoming Docker webinars at docker.com/webinars, and also check out docker.com/events for upcoming customer events. Thank you again for joining us today, and have a great day.